Okay, guys. So unfortunately, I cannot be there with you, due to what some people might say is health and safety protocol. So you're gonna have to go over this lesson with this video. Okay. Now the good news is this is gonna be just a lot of review, so I don't think it's gonna be challenging for you guys. So first here we're gonna graph lines just by plotting, right? So here's the equation, and we're gonna plot the points, and then we're gonna put them on the graph and make a line from that, right? So I would choose the points, So 0 would be in the middle, so I go down to -1, -2, -3, and then up to 1, 2, and 3. So these points are pretty much standard when you want to figure out any kind of graph, right? A line is pretty simple, but when you do some kind of a new function or a new graph, you want to pick points that are closer to the origin to try and figure out, what the shape looks like. So here, if I put 0 in for x, I have 2 times 0 plus 4, that gives me 4, right? And I put in -1. So 2 times -1 plus 4, that gives you 2. I put in -2. So 2 times -2 plus 4, that gives you 0. And so on. You kind of you start to see a pattern here, because straight lines are um, arithmetic sequences, right? So it just goes in a linear pattern. So you have 8 and 10 and so on. All right, so there's a bunch of points. So you have your graph really. 0, 4, -1, 2, -2, 0, 3, -2, and so on and so forth. Of course, it makes a straight line. We all know that because, you know, it's a linear graph, linear equation. Same thing here, but now this is no longer linear, right? Because the x is not in the first order; it's in the second order. So is this x squared? So again, go to 0 and then -1, -2, -3, 1, 2, 3. So I put 0 here. 0 squared minus 1 is -1, right? -1 squared. Make sure you put parentheses around the -1, right? Because it's the whole thing squared. So -1 squared minus 1, which gives you 0. -2 squared minus 1 is 3. And -3 squared minus 1 is 8. Okay, 1 minus 1 here. So 1 squared minus 1 is 0. 2 squared minus 1 is 3. And so on. It's the same thing. All right, so 0, -1, -1, 0, 1, 0, -2, 3, 2, 3, -3, 8, 3, 8. Okay, so it's a parabola as we expected because it's the second degree polynomial. There we go. So that's how you plot, right? You kind of plug in these x's for the values for the x's, and then you solve for the y. Okay, not a big deal. We move on to this. This is the third order. This is cubic. Okay, let's see what it looks like. So you go into 0 for x, -1, -2, -3, 1, 2, 3. All right, so 0 cubed plus 8 is 8. -1 cubed plus 8 is 7. -2 cubed plus 8 is 0. And -3 cubed plus 8, 27. Plus 8 is -19. Okay, 1 squared, 1 cubed plus 8 is 9. 2 cubed plus 8 is 16. And 3 cubed plus 8, 27 plus 8 is 35. There you go. All right, so just a bunch of arithmetic stuff that we have, arithmetic stuff that we have to do. So here's 0, 8, -1, 7, 1, and 9, 2 and 16. So 2 is already like off the graph, but -2 is at 0. And then -3, that's way far down. So the graph looks like that. And it stretches out very, very quickly because it's cubic. So it climbs very quickly. And so there's your the graph of a cubic function. Okay. Um, so again, all those problems is just for you to go through how to plot points and kind of figure out. That's the most basic way of figuring out what the graph looks like, right? Just plotting points. And here are some other skills that we gotta have. The next one is finding the intercepts. So the x-intercept is when y is equal to 0. So the point is always going to be x for some value and then 0 for y. And then y-intercept is when x is equal to 0. So the point is going to be 0 for x and then some value for y, like that. So here, let's find the x-intercept and y-intercept for these problems. X-intercept is when y is equal to 0. So you plug 0 in for y, and then you solve for x. All right, so you add 12 to both sides. 12 is equal to 3x divided by 3. X is equal to 4. So your x-intercept comes out to be x is 4, y is 0. Okay? And then to find the y-intercept, y-intercept is when x is equal to 0, right? X is equal to 0. So you put 0 in for x and solve for y. All right, so I get -12 for y, and my x is 0. And there is my y-intercept. Same exact thing no matter what kind of function you have. Okay, so x-intercept, again, is when y is equal to 0. I put 0 in for y, and I solve for x. Right, so this one you can just add 4 to both sides. So I have 4 is equal to x squared. And to solve for this, I square root both sides. So I get positive and -2 is equal to x. So here you get, remember when you square root, you get a positive and a negative. So you get two different values for x, okay? A positive 2, and y is 0. And then a -2, y is still 0. So you get two different x-intercepts. Here you do y-intercept. So x is equal to 0. Put 0 in for x. And y comes out to be -4. So you get 0, -4. Same thing here. I'm going to do the x-intercept. So y is equal to 0. So I put 0 is equal to x squared plus 4x plus 3. This one, to solve for it, I got to do factoring, right? So I factor this out. Now, remember, I told you guys to learn how to factor. If you don't know how, go back to the video I posted before, and figure out how to factor these quadratics. So I get that. So 0 product property. There you go. So x is equal to -3. X is equal to -1. The two values, the two x-intercept would be -3, 0, and -1, 0. And then the y-intercept is when x is equal to 0. I put 0 for x, right? 0 squared plus 4 times 0 plus 3, which gives me 3. So 0, 3 is my y-intercept. All right, symmetry. A graph can be symmetry mostly to three different ways, right? The first one would be it would be symmetric about the x-axis. Oh Lord, no, that's not what I want. No, what is going on? Excuse me. I'm not even gonna cut this out of the video. I don't want to edit it, so you're gonna hear all this. Okay, so the first way that it can be symmetric is about the x-axis, and sometimes we say that it's reflected across the x-axis, right? So whatever it looks like on the top is going to look like on the bottom, below and above the x-axis. So when that happens, the definition for it is for every point x and y on the graph, if you have a point x and y, then the point x negative y is also on the graph. Okay, so imagine if you have a graph that looks like this, like that. So you have this point here. At that same x, you're going to have the same point down here at negative y. Positive y here and negative y down here. See, it looks exactly the same. Okay, at the same x, you have a positive y and a negative y. That's what it's saying. If it's symmetric about the y-axis, then for every point that you have point x and y, you have a negative x and a positive, and the same y. So what it's saying is, if you look something like this, like if you have at some given point y, right, you have a positive x, then that same y is going to give you a negative x on this side. See, then it's symmetric across the y-axis, about the y-axis. Okay, sometimes it's symmetric about the origin, meaning it's reflected both across the x and the y. Then for every point x and y on the graph, you have a negative x and a negative y. So for example, you have something that looks like this. Here's a positive x, positive y. You're going to have a negative x, negative y down here. So it looks like that. There you go. All right, so determining the symmetry of these graphs, you can just plug in points. Just do the same thing, plug in points, and see what kind of values you get, right? But when you do these, it's easier to kind of decide um, what which variable is easier for us to plug in points. If I put in 1 for x, I can solve for y pretty easily. If I put anything in for x, I can solve for y. But if I put in a random value for y, it's hard to solve for x. Like if I put in 4 for y, like what's x going to be? What number cubed gives you 4? It's really hard to do, right? So I'm going to put values in for x instead of y. So 0, -1, -2, -3, 1, 2, 3. All right. If I put in 0 for x, 0 cubed is 0. If I put in -1 for x, -1 cubed is -1. So it's really easy if you put values in for x, So here I put in -2 cubed, right? That gives you -8. Here, -3 cubed. That gives you -27. So on and so forth. Okay, now that you have your values, you have to decide, like, what kind of symmetry do I have? Or do I have any kind of symmetry at all? Right? So here, look at these values here. Here, the first one is -3, -27. And when I change the sign of that x, the sign of y also changed. So it goes from x and y become to -x, -y. So this is the case of the symmetric about the origin, right? This is about origin. So you have the same value of x and y, but they both change sign. All right, so it's about the origin. Now for this second problem, it's easier if we plug in points for y. All right, because if I put in like 1 for x, I have to solve for y. That's really hard. I have to divide both sides by 4 and then square root both sides. It's easier if I put in numbers for y. So I'm going to go -3, -2, -1, 0, 1, 2, 3. All right. So I put a 0 in for y here. So 4 times 0 squared, that gives you 0. This one is 4 times -1 squared is 4. The next one is 4 times -2 squared, which is 16. Next one is 4 times -3 squared, which is 36. All right. Same thing down here. 4 times 1 squared is 4. 4 times 2 squared is 16, and then 36. You see, for these values here, the x stays the same, but the y changes sign. Right? So which case is that? X stays the same, but y changes sign. So that is the case of that one, the first one, right? So it is symmetric about the x-axis. And I do the last one. Yeah, this is a long lesson. I know. Making videos, I try not to make them more than 15 minutes, but this is a long one. But it's easy, right? It's not hard. Here, which one do you think is easier to plug points in? Plug values in? X, of course. Right? I put values in for X and I just solve for Y. It's easy. So -3, -2, -1, 0, 1, 2, 3. I put -3 in. I'm going to do a lot of this in my head, but you should work this out. 4 times 9 is 36 over 9 plus 1 is 10. Okay? Next one is 4 times 4 is 16 over 5. Next one is 4 over 2. And then next one is 0. And then 1 is going to be 4 over 2 again. And then 2 is going to be 16 over 5. And then 36 over 10. All right, so the x changes sign while the y stays the same. X changes sign while y stays the same. So, see, x changes sign, but the y stays the same. So this is symmetric about the y-axis. All right, so we're gonna go in more into linear function here. So when you are given 2 points, say point P, x1 and x2 as the coordinate, and point Q with another pair of coordinates. So the slope between these 2 points would be, so slope is the change in y over the change in x. Okay, so to find the change in y, this is x1, y1. So you have y2 minus y1 over x2 minus x1. And that gives you the value of the slope. So again, the example right here to find the slope between the point A and point B is going to be, so you call this x1, y1, x2, y2. You just name them. It doesn't matter which one's 1, which one is 2, as long as it's consistent. You can call this x2 and y2, and this is x1 and y1. So the slope is going to be y2 minus y1 over x2 minus x1, which is -6 minus 4 over 3 minus -2, which gives you -10 over 5, which is -2. Now that's the slope. I'm not even going to graph this. Forget it. All right, let's talk about the slope-intercept form. When you're doing linear equation, there are two useful forms that we should know. First one is slope-intercept. It is y equals to mx plus b, where m is the slope and b is the y-intercept. And the point slope form is y minus y1 is equal to m times x minus x1. A lot of people get confused with the point slope form, but it really is just this. M is the slope still, so that's not confusing. And x1 and y1 is the point that you know about that line. X and y, the one that does not have the subscript, those are your actual x and y, right? Those are arbitrary. And x1 and y1 are numbers, okay? They're not variables, they're numbers. We call them x1 and y1 because they're just a particular point on the graph. Okay. Uh, if that confuses you, I think the example is going to help. Right. So here we're going to write some equation of these lines. Okay. So they give you the slope and they give you a point. Slope and a point. So which form is easiest to use? Of course, point slope, because you have a slope and a point. So this would be your x1 and y1. And you just plug that in. Y minus y1, right? Y minus 2 is equal to m, which would be the slope, which is 4 times x minus what's x1? 1. And that is your point slope form. Okay, that's the point slope form. And if you want to convert this into slope intercept form, it's really easy. You just multiply it out. You multiply this out, so you have y minus 2. I multiply the 4 in like this, so I have 4x minus 4. And I add 2 to both sides. So I have y is equal to 4x minus 2. There it is. That's slope intercept. This is point slope, and this is slope intercept. And when they give you 2 points, you have to find the slope first. So slope is going to be, y2. So let's call this x1, y1, x2, y2. And then you find the slope, y2 minus y1. So 5 minus 4, and then 2 minus negative 3, which gives me 1/5. So now you have the slope and the points. So point slope would be uh, y minus y1. Now, at this point, doesn't matter which one. Doesn't matter if you put y1 here or y2 here, as long as you use that one particular point. So I can put 5 here or 4 here. If I put 4 here, then I have to put negative 3 here. They have to match. If I put 5 here, then I have to put 2 here. But yeah, this would be your point slope. And then from there, if you want to do slope intercept, you multiply it out again. Um, it doesn't work out very well. Anyways, we can do that. Doesn't matter. So multiply the 1/5 in. You have x over 5. This is plus 3. So plus 3/3. And then you add 4 to both sides. 4 and 3/5. And that would be your slope intercept form. Another way to do the slope intercept form, let me show you real quick, just so you have all the different ways. Once you have the slope and the point, and you don't want to go through slope intercept form and then convert it, you can just put y is equal to m x plus b, and then y is, so you can put in the values for y and x and m and solve for b. So I want to take the 2 and 5 and I plug that in for x and y, right? So y is 5, m is 1/5, and x is 2. Right, so you subtract 2/5, b is equal to 4 and 1/5. No, 4 and 3/5. Yeah, same thing. And then once you have that, you plug it in there. So y is equal to 1/5 x plus 4 and 3/5. So it looks exactly the same. So those are the different ways that you can find the slope, intercept form, and the point slope form. Oh, by the way, guys, you have a quiz on these things on Monday, the next Monday, the upcoming Monday. There won't be time for review also. So because all these things are reviewed from Algebra 1. So we're not expecting to to have to give you a lot of review time. Okay, now if two lines are parallel, what do you know about the slope? Well, they have the same slope. That is, m1 is equal to m2. If two lines are perpendicular, then their slopes are negative reciprocals of each other. Reciprocals. So m1 is equal to negative of 1 over m2. Okay, so here is a line. They want you to find the equation of a line parallel to this, but contains this point. Okay, so if it's parallel to this, the slope has to be the same. So the slope has to be 2, right? And it has that point. So you can write the equation in slope-intercept form easiest. So y minus y value equals to slope times x minus x value. Well, there's your equation. Again, if you want to convert this to slope-intercept form, would be multiply it in. This becomes a positive, so plus 2, and then add 2 to both sides. Y is equal to 2x plus 4. Either way, both of them are the same thing. Okay, one is point slope. This is point slope. This is slope intercept. They want one that is perpendicular to this and goes through this point. Perpendicular to this means this. So this one m is 12, right? So the m that we want, perpendicular to that, would be negative 1 over 12. And then it has that point. Okay, so y minus the y value is equal to negative 1 over 12 times x minus the x value. There you go. All right, so try to do the homework. I don't know when I'll be back, but hopefully soon. And if not, we'll probably have to do a couple more video lessons before I return. We'll see. See you guys soon.